Hi, this is Todd Signetti. I'm a Senior Product Manager with AWS Cryptography, and today I'm going to be talking about AWS Certificate Manager Private Certificate Authority. So we'll go through some background and use cases and explain how the Private Certificate Authority is used and what kind of certificates it issues and how you can use certificates from the Private CA. I'll give a brief demo, and then we'll talk about the benefits and features of the service, go through pricing and regions, and then wrap up with some additional resources to learn more. So ACM Private CA, which stands for Private Certificate Authority, is a service that helps you manage the lifecycle of your private certificate in a way that's highly available without upfront investments and ongoing maintenance costs of running your own private CA. The service can renew your private certificates automatically on your behalf, and you can create and deploy private certificates for AWS resources using the AWS Management Console or AWS APIs or with the AWS command line interface. APIs allow your developers to create and deploy private certificates programmatically. You also have the flexibility to create private certificates for applications that require custom certificate lifetimes or custom resource names. ACM Private CA gives you a single interface for managing private certificates with a secure pay-as-you-go managed private CA service. ACM Private CA is primarily designed for TLS, SSL, client, and server certificates. And I'll talk about the applications a little bit more in the next few slides. But with custom subjects, other applications are also possible. So the first question is, why use certificates, and particularly why use SSL TLS certificates? And why do I need them? Why do you need them? You can use SSL TLS certificates to establish the identity of websites and servers on the internet or internally on your network. And we'll talk about the differences between public and private certificates in a bit. But certificates in general are used to secure those network communications with sites and applications that use HTTPS over connections secured with TLS and SSL. Users connecting to applications or websites with browsers see a lock icon to indicate the secure connections. And browsers warn users if the certificate is expired or revoked or doesn't match the site name. And in the near future, some browsers will even start to indicate that sites that use HTTP rather than HTTPS indicate that they're not secure. So some of the use cases our customers are using Private CA for today are to create server certificates that protect and identify internal servers. Examples include Apache web servers, Tomcat, WebLogic web application servers, or to establish secure communications between server to server, such as when your web application is talking to your database. And those are on EC2 or instances or servers you have in your data center. You can also use ACM Private CA certificates to secure connections to AWS resources, such as Elastic Load Balancers, CloudFront distributions, and API gateway endpoints. Next, client certificates. Those are server certificates, but client certificates identify a client in a TLS connection. And you can use client certificates for two-factor authentication. For example, if you want to give a third-party access to your API, you can give them a certificate that allows them to connect in addition to the other authentication or keys that they use to connect to your API. ACM Private CA certificates also work well for customers who want a replacement for self-signed certificates, especially if you want to automate your certificate management through APIs. Rather than using self-signed certificates, managed certificates issued through a Private CA can give you more repeatable and manageable automation and avoid expirations. Finally, IoT device certificates for customers who are manufacturing a lot of devices. Device certificates identify the device, and ACM Private CA can issue certificates in volume to identify those devices. This is one example of elastic load balancing, where a certificate is deployed on an elastic load balancer to identify an application running behind the load balancer. And in this case, this is the front end, so a browser connecting to this site would see the certificate and would be able to establish a secure connection to the site. But you could also deploy a private certificate on the instances individually and use back-end instance authentication so that the load balancer only connects to trusted instances. And there's lots of other applications for which you can use private CA. This is one example. So I want to talk about the difference between public and private certificate authorities. And certificate authorities are essentially just the infrastructure and processes used to issue certificates. When you open a browser and access a public-facing web page or application secured with a public certificate today, the web server presents a certificate to your browser that identifies the site. Public certificate authorities, or CAs, create or issue certificates after validating the identity of a site using one of a few mandated validation methods. These include DNS validation or email validation. There's other methods that include more extensive validation processes like extended validation or EV certificates. Those are all processes that the CA uses to identify the domain owner and to make sure that the domain owner is identified before issuing the certificate. And the reason CAs have to do that is that public certificates are trusted by default in most browsers and operating systems. So when your browser recognizes a certificate issued by a CA that it trusts, it can establish a secure connection to the site. It doesn't require you to add trust for the public CAs into your browser or operating system. That trust is already established by virtue of the fact that it's a publicly trusted certificate. Now, in the same way that websites use public certificates to prove identity and ensure secure connections with consumers on the internet, enterprises use private certificates to identify and secure applications, servers, services, and devices within their organizations. Enterprises prefer private certificates over public ones to support customization in ways that public certificates don't allow. Private certificates don't have the validation requirements of public certificates. So your organization can determine their policy for issuing private certificates without having to go through the validation methods that public CAs are required to implement. And private certificates are not trusted by default by browsers and operating systems. To be trusted, the root certificate authority for your organization must be added to the trust stores of the operating systems and browsers in your environment. Most organizations have a method already established for distributing the root CAs for their environment to all of the operating systems and browsers. You can create private certificates by deploying your own private CAs and software and so on, but operating and maintaining private CAs is complex and expensive. Private CAs require infrastructure and expertise to operate securely, and all of these things add up to additional expense. There's the cost of the software, there's cost of maintaining the hardware that's used to store securely the private keys of the CA, and all these factors add up to additional cost and expense. And furthermore, as you want to deploy certificates automatically to resources that are dynamically changing in a cloud environment, those requirements become more challenging even still. So with auto-scaling or CloudFormation and automation, there's a very dynamic environment that's created, and we want to identify all those resources, and certificates provide a great way to do that. But in order to support that, we need a flexible and agile private certificate authority that can issue those certificates in a way that's dynamic to support the changes in the environment and to be able to issue certificates at scale as these resources are created and destroyed. So the solution is a secure API-driven private CA service for issuing certificates and vending revocation information. ACM Private CA, and that's essentially what ACM Private CA does. And the way that ACM Private CA works is that it chains up to your existing public key infrastructure, your existing root CA or intermediate CAs, and you issue a certificate for the CA, and that allows the private CA to operate and issue certificates in your environment. So as a CA administrator, you can create a CA, and at that point, you can export a certificate signing request to your root or intermediate CA. Presumably, you have a root or intermediate CA established already, but if you don't, for testing purposes, you can certainly create one through a tool like OpenSSL. We wouldn't recommend that for operations or production, but for testing, that would be just fine. So once you have this certificate signing request, you take it to your root or intermediate CA, and you issue a certificate that essentially allows the subordinate, the private CA, to issue certificates that are trusted in your environment, that chain up to your existing root or intermediate CA. You take that certificate back to your private CA, you import it into the private CA, and that essentially activates the private CA and allows it to start issuing certificates that are trusted in your environment. Now, I've gone through this in principle, but now I'm going to take you through a demo that shows you how to create a certificate authority, and then I'll show you how to issue certificates from it once it's created. So I'm starting from the AWS Management Console. This is the Certificate Manager console, and I have the option here to manage my private certificate authorities, private CAs. First thing I do is click Create a CA, and I choose Subordinate CA because I'm going to have a CA that chains up to my existing root or intermediate CA. At this point, I'm just giving a name to my CA for the organization, and OU, and a common name. This helps me identify the CA within my organization. And I'm going to choose Test Issuing CA G4, just as a name I picked. Next, I choose the key algorithm. That is the key algorithm used for the private keys of the CA. I have a few choices here. RSA 2048 is the most common, and that's what I'm going to choose for this. Next, I'm going to choose the certificate revocation list parameters. And the certificate revocation list is a way to distribute information about which certificates have been revoked. This is important because once a certificate is revoked, we want to make sure the clients who depend on the certificate are aware that it's been revoked and stop trusting it. So ACM Private CA includes the generation and distribution of certificate revocation lists. The way that CRLs are distributed are to be placed into your S3 bucket, and the clients that depend on the certificates can access the CRL through the bucket name or a C name that you give, which is basically just a reference, an indirect reference to the bucket, but through a friendlier name. So I'm going to choose the S3 bucket name here. I'm actually going to ask to use an existing bucket. I won't create a new one, but I could if I wanted to. And here I'm going to give a more friendly name so that the certificates that I issue will contain this name, and clients will use this name to reference the revocation list. Once I have all that information entered, I go ahead and click Confirm and Create. ACM Private CA is now going off and creating a private key and creating the CA. At this point, the CA is ready, but I have to take the steps that I described before in the previous slide, which is to export the certificate signing request and then import the certificate, the CA certificate that is signed by my intermediate or root CA. So to do this, I either copy the certificate signing request or export the CSR to a file, and I take that off to my intermediate and I get it signed. How that process works for your environment may be different, may depend on your PKI administrator At this point, then, we're ready to, once we have a signed certificate, we can import it back into the private CA and paste the certificate body in the chain, review that information, and confirm an import. At this point, I was successfully able to import it. I have an active CA. That means I'm ready to issue certificates for this environment. And I can look at some of the status information that the console shows. The CA certificate is here with the name that I gave it, test issuing CAG4. The expiration date and the certificate and the certificate chain are here as well. I can also look at the revocation configuration that I entered previously and the time period for the CRL lifetime. The next thing I can do is just show you quickly how to generate an audit report. The audit report includes all of the information about the certificates that have been issued. So whether a certificate is in the issued state or revoked state, all the certificates issued from the CA will be included in the audit report. So I can hand this report to my auditor and tell them exactly which certs I've issued, and they can double check and confirm that the CA has only issued certificates that have been, authorized and intentionally issued. So to generate the audit report, I just like I did with the CRLs, I can either create a new bucket or use an existing bucket. I'm going to use an existing bucket in this case. And I can also select, after I choose the bucket, I will select the output format, either CSV or JSON. I'm not going to generate that audit report, but that is the process that you would follow to do so. At this point, I have an active CA, and I can go through the next step of issuing a private certificate from my private CA. To do so, I'm going to start again in the AWS Management Console. I'll navigate to the Certificate Manager, and I'll see the same options I had before, Certificate Manager and private CAs. In this case, I'm going to use the Certificate Manager to request a new private certificate. And here I have the option, you can see, either to request a public or private certificate. That's one of the benefits of ACM Private CA. I can request either through the same workflow. In this case, I chose private CA. I select the private CA from the drop-down, and I click Next. At this point, I just need to enter the name of the resource I want to identify. I'm going to choose server.internal as just a DNS name for the resource I want to identify. Once I have that entered, I click Confirm and Request, and ACM is going off and requesting the private certificate. I'll talk more about that process in a bit. At this point, the certificate is issued successfully, and it's ready to be used. I can use it with a load balancer or an API gateway endpoint, or I can select the certificate and export it and use it with an EC2 instance or an on-premises server. To do that, I just click Export. I enter a passphrase. This is used to encrypt the private key for export. It's easy to decrypt the private key using a utility like OpenSSL. At this point, I'm done. I have the exported certificate. It's issued. I can take it to my server or my application and deploy it, and or I can deploy it on AWS on an elastic load balancer or an API gateway endpoint. Now, the nice thing about AWS Certificate Manager Private CA is that everything that I just showed you can be automated through APIs. So everything you saw in the console is really intended to be doable and intended to be done through APIs. And that really will allow you to automate your certificate lifecycle management, which is an important part of the service and what we offer. So the benefits of ACM Private CA: first, to operate a secure and managed private certificate authority. It's a managed service. It automates the administrative tasks such as provisioning hardware, software patching, high availability, and backups. You don't have to worry about any of those things. It's all included as part of the service. Private CA gives you a way to manage the life cycle of your private certificates. So ACM, once the certificate is issued, for certificates that are used on AWS, ACM automatically renews them and deploys them for use with things like load balancers and API gateway endpoints. ACM can also renew certificates that you export, but you have to have client logic that picks up the renewed certificate and deploys it. The service enables developers to create and deploy certificates with just a few API calls, so it's really designed to be developer-friendly. You can use ACM Private CA to create and deploy customized private certificates, such as certificates with custom lifetimes or resource names. And finally, the service is more cost-effective compared to traditional commercially available options. ACM Private CA lets you pay monthly for the service and any certificates you create. The more certificates you use, the less you pay per certificate. So let's get into each of those benefits and go through them. ACM Private CA manages hardware security modules. These are FIPS 140-2 Level 3 devices designed to protect the private keys against compromise or against unauthorized access. ACM Private CA also is controlled by IAM policies, so you can write policies to determine who or what has access to the private CA and what they can do. As I showed, the generation of the certificate revocation list is published by ACM Private CA. That allows clients to determine the status, the revocation status of each certificate. And finally, ACM Private CA allows you to generate audit reports so you can see the status of all of the certificates that you've issued. All of those combined add up to making ACM Private CA secure and operationally sound for your environment. ACM Private CA's APIs are logged into AWS CloudTrail, which is an AWS service that captures API calls and delivers the log files to your S3 bucket and maintains the API call history. It tells you all of the calls that you made, the requests, the API address from which the request came, and additional information about the API calls. A little bit more about ACM, AWS Certificate Manager, as a way to manage the certificate lifecycle. We've tried to make it simpler to obtain and provision certificates. ACM takes care of what we call the muck, all the things that are difficult or painful about certificate management, including generating private keys, generating certificate signing requests, managing the renewal process. ACM takes care of all of those. ACM also provides free public certificates for use on the AWS. A few more benefits of ACM and using it for certificate lifecycle management. When you use ACM to request certificates from your private CA, ACM takes care of generating the private keys, renewing certificates automatically, and makes it easy to deploy certificates to resources on ACM integrated services like Elastic Load Balancing load balancers. ACM manages certificate renewals for you. ACM is designed to protect the private keys used with each ACM managed certificate. So the service uses strong encryption and key management best practices when protecting and storing private keys. If you want to customize certificates issued through ACM Private CA, you can. There's one trade-off, though, which is that custom certificates aren't managed in ACM today. So if you want customized certificates, you can manage the private key and renewals yourself, and the benefit you get is additional flexibility. You can specify custom lifetimes, validity periods of the certificates you issue. You can specify the key algorithms and signing algorithms that you use, RSA 2048, 4096, and ECDSA key algorithms. You can choose all of those options when issuing a certificate directly to ACM Private CA in standalone mode where you manage the private keys. Now, if you want ACM to manage the private keys and your certificates look like most TLS certificates, where they have a DNS name and they're using RSA 2048, the best solution in that case would be to use ACM Private CA with managed certificates managed in ACM. You can write code to automate certificate management in your programming language of choice using the ACM Private CA and ACM APIs. The SDKs make it easy to integrate efficiently with your development environment, and you can also write scripts or one-off commands using command line tools to interact with the service. Here's a few examples of ACM Private CA APIs. The most common ones are on the left. Examples include create certificate authority, issue certificate, get certificate, and revoke certificate. But the interface is full-featured, allowing you to manage certificates completely through the APIs. ACM Private CA pricing works the following way. You pay monthly for the operation of each ACM Private CA until you delete it, and that charge is $400 per month for each CA. You pay a fee for each certificate that you issue. Public and private certificates are free for use with ACM integrated services. So examples include Elastic Load Balancer certificates or certificates used with API Gateway. If you issue those and deploy them directly on those services, you pay nothing additional for those certificates. You pay for certificates for which you have access to the private key. So either if you request certificates through standalone mode, or if you request them through ACM and export them, you pay for those certificates. Up to 1,000 certificates, you pay 75 cents. 1,000 to 10,000, you pay 35 cents. And 10,000 or more, you pay 1/10 of a cent for those certificates. So the intent of our pricing is to allow you to scale up and automate certificates, and as you get to high scale, you pay very little additional for each certificate that you issue. We also have a free trial. The first 30 days of the CA operation are for the first CA that you create. Those first 30 days of CA operation are free for new accounts. You pay only for the certificates you issue during the trial. ACM Private CA is available in these regions, and London is coming soon. So just a few key takeaways. ACM Private CA, it's a fully managed private CA service. You don't have to worry about standing up software, patching it, standing up hardware security modules and interfacing to them. We take care of all of that. We take the complexity out of managing a private CA. ACM can manage the lifecycle of public and private certificates. So if you want to manage your public and private certs in one place, ACM gives you the opportunity to do that. And ACM Private CA is designed from the ground up to be friendly for the AWS cloud and to issue certificates for dynamic resources that you create. It gives you agility. It gives developers a way to automate certificate management, as well as the ability to customize certificates for cases where you want custom subject names or custom validity periods. ACM Private CA integrates with other AWS services like identity and access management, allowing you to specify policies for access to the CA, CloudTrail for logging all the API calls, tagging for identifying resources, and more functionality and value. Because of that integration, it makes it easy to operate and include with the rest of your AWS resources. So here are a few links that you can use to find out more about ACM Private CA. There's the detail page, FAQs, and our user guide. That's all I have for now, and at this point we'll take questions.